This guy, Adam Rees, is a Nobel Prize winner who fundamentally changed how we think about our universe. Well, now he believes the theory of the universe born out of his groundbreaking discovery might be wrong. And if he's right, then everything we think we know about how the universe will end could be completely backwards. Rees won the Nobel Prize back in 2011 for proving something mind-blowing, that the expansion of the universe is actually speeding up. And his calculations led to the establishment of dark energy, this mysterious force that makes up 68% of our known universe. Dark energy has this repulsive gravitational effect that is literally pushing galaxies apart. The theory works like this. As more space is created between galaxies, dark energy's repulsive force gets stronger, which speeds up the universe's expansion even more. Eventually, the idea is if you looked into a telescope far enough into the future, all other galaxies would be completely driven out of sight. Rees's work became the foundation of what is called the Standard Model of Cosmology, basically our best explanation for how the universe started and how it will end. For a while, cosmologists knew that the Standard Model did have some problems. For instance, 96% of our universe, according to this model, is made up of dark energy and dark matter, and yet not a single scientist has been able to detect either one. So for Rees, there was clearly some major missing piece here. No one had ever measured the actual rate of the universe's expansion with real precision. To do that, you would need to know exactly how far away the galaxies are, which happens to be Rees's specialty. What he does is he photographs stars as they're exploding, in other words, a supernova, and measures how bright they are. The basic principle is simple. The dimmer the light, the farther away the galaxy. It sounds simple, but I cannot stress enough how incredibly complex this is. You have to subtract out light from surrounding stars, the glow from our Milky Way and our sun, factor in dust clouds that may be blocking light, and even compensate for the fuzziness caused by the telescope itself. Every time Rees did his calculations, he kept getting different answers than what the standard model predicted. See, most cosmologists don't measure the distances of galaxies. Instead, they look at the afterglow from the Big Bang and extrapolate the expansion rate from that. There's only one problem with this. Those calculations are based on the standard model and is thus assuming that the standard model is correct. So what Rees is doing, like all of us learned in math class, you gotta show your work. He's going back and actually measuring the distances of the galaxies, and with each measurement, it became clear that there was a discrepancy. Rees's findings became such huge drama in the cosmology world that they actually gave it an official name. They called it the Hubble tension. And the tension is real, because if Rees's calculations are accurate,